Hello. Hello again. It's Josh again, and I'm here to do the 2021 VCAR Methods Exam 2 paper. I'm going to be starting with the extended response. Again, I haven't touched this at all, so I'm just going to be doing this completely impromptu. Just to note that all contents here is owned by the VCAR, and I don't claim to own any of it, and VCAR doesn't endorse me at all. I'm just here to do the paper using my own brain, and none of this is endorsed by the VCAR. Perfect. Let's get started. Section B. I'm going to start with Section B first. I've got my notes beside me, and I've also got my trusty Kaz with me. So, time to get started. It's 5:41 p.m. A rectangular sheet of cardboard has a width of h centimeters. Its length is twice its width. Squares of side length x centimeters, where x is larger than 0, are cut from each of the corners as shown in the diagram below. The sides of the sheet of cardboard are then folded up to make a rectangular box with an open top as shown in the diagram below. Assume that the thickness of the cardboard is negligible and that the volume of the box is greater. Okay. They don't really need to provide this information, I think, but that's fine. A box is to be made from a sheet of cardboard with h equals 25. Show that the volume V box in cubic centimeters. Okay, so that's just V box is equal to length times width times depth. So length is 2h, which is 50, minus 2x. So that's 50. 50? Yeah, 50 minus 2x. That's the length. The width in this case is h is 25, so that's 25 minus 2x times the height, which is x. And then you can just factorize the 2 out, so you get 2x 25 minus 2x 25 minus x. Great. State the domain of V box. Okay, so the domain of V box that's just the values of x that can be had. H is 25, which means that x is less than, so 2x has to be less than 25. 2x is less than 25, and x is larger than 0, obviously. So x is an element of 0, sorry, not including 0, 0, because it has to have height, so 25 over 2. Great. Find a derivative of V box with respect to x. Okay, so what I'm going to do here is I'm going to define my function of v comma x is equal to 2x, defined is equal to 2x times 25 minus 2x times 25 minus x. There we go. And then I have to derive it. So that's menu for 1 x v of x, and that's equal to that. So I'm going to write that in. Oh, that's equal to, so v box dash of x is equal to 12x squared minus 300x plus 1250. Calculate the maximum possible value of the box and for which value of x this occurs. Okay, so again, I'm going to bring back my Kaz. That's solve. That is equal to 0. You get x. So x is this value. I'm just going to approximate it to make sure. Well, I know it could be either. Which one is within the domain? This one's not within the domain. This is within the domain. So I'm just going to write here. So it will have to be this one here. So the 5 one. So v dash of x is equal to 0, and so x is equal to 5.28. Actually, I'm going to have to put the actual cert in. Negative 25 root 3 minus 3 over 6, and then I sub in v. So I get v of negative 25 root 3 minus 3 over 6. And that's equal to v dash of, I'll just copy that in. The great thing about using a computer is you can do this. 15625 square root 3 over 9. There we go. Waste minimization is a goal from these cardboard boxes. Percentage waste is based on the area of the sheet of cardboard that is cut out before the box is made. Find the percentage of sheet that is wasted when x is equal to 5. Okay, well, that's just, you have the box. The box has area 25 times 50, which is 1250. And if x is 5, then you have 4 squares. So 5 squared times 4, that's 100. So 100 over 1250 is equal to 100 over 0.08, so that's 8%. There we go. Now consider a box made from a rectangular sheet of cardboard where h is larger than 0 and the box's length is still twice its width. Let vbox be the function that gives the volume of the box. State the domain vbox in terms of h. Wait, h is larger than 0. Okay, so h isn't 25 anymore, it's just larger than 0. If we go back up here, the domain of h, well, set the domain of, oops, that's the one there. Set the domain of vbox in terms of h. Well, what's the largest h can be? Can't h just keep getting larger and larger? Oh no, I think it's just, yeah, it's just saying get that. So I'm just going to take the same domain and it's just 0h over 2 because h is not 25 anymore, it's just h. Find the maximum volume for any such rectangular box V box. Find the maximum volume for any such rectangular box V box in terms of h. Okay, so what we have is V box dash box is equal to 0. The volume of the box is now 2x. The volume of the box is now 2x times h minus x, h minus 2x, h minus x. It's equivalent to this except h is no longer 25. That looks correct. So then v box of 0, oops, v of x is equal to 0. What do we get there? I'll just get my cas back. We end up getting I'll just say vv of x is equal to 2x times h minus 2x times h minus x. So 2x, h minus 2x, h minus x. And then solve vvx. Okay, solve the derivative of that is equal to 0. So menu 3, 1. Oops, I meant menu 4, 1. X vv of x is equal to 0. So that's x. What's wrong there? Oh, I actually haven't defined this properly. Okay, we get those two answers again. And then the maximum volume, well, I'll just sub it back into VV of x of this. I'll just move this here. Yeah, so it'll have to be a smaller one again, which I believe they're giving first. Actually, I'm not sure one is smaller than the other. I'm going to put in my domain here. What's my domain? 0 x h over 2. So this is the only answer. It turns out it's the one on the right. I could have checked that manually, but I couldn't be bothered doing that because we have our cas, and then we sub that back in. So we get h cubed root 3 over 9. Great. Now consider making a box from a square sheet of cardboard with side lengths of h centimeters. Show that the maximum value of the box occurs when x is h over 6. Okay. I think this is just a similar thing. V of x is equal to x times h minus 2x squared, and I'm just going to derive this by hand, I think. Derive the first times the second, derive the second times the first, that's equal to 0, and then I substitute h out, or I'm just going to use a cas for that. Or I could sub it into that equation. I'm just going to use a cas for that. VVV of x is equal to h minus 2x squared minus 4 times h minus 2x x solve VVV of x is equal to 0 x. Okay, so we end up getting x is equal to h over 6, which is the correct answer. X can't be h over 2 because that's outside our domain. Great. First question done. 4 rectangles of equal, sorry, you didn't see that before. X is equal to h over 6. 4 rectangles of equal width are drawn and used to approximate the area under the parabola y equals x squared from x equals 0 to x equals 1. The heights of the rectangles are the values of the graph. Okay. At the right end point of each rectangle is shown. Set the width of each of the rectangles, 1 over 4. Let's find the total area of the 4 rectangles. That's just, x squared. I'm going to use a calculator for this. I'm going to define f of x equals x squared, and the total area is 0.25 times f of 0.25 plus f of 0.5 plus f of 0.75 plus f of 1. That's 0.46875. Okay. Find the area between the graphs of y equals x squared, the x-axis, and the line x equals 1. So x equals 1 is here, the x-axis is here. Okay. What? Isn't that just a normal integral? X squared dx, the x-axis, and the line x equals 1. So that's just 0 to 1. I'm just going to do this by hand. You guys can't see that again. X cubed over 3, 0, 1 is equal to 1/3. Right. The graph of f is shown below. Approximate from -2 to 2 using 4 rectangles of equal width and the right endpoint of each rectangle. Okay. Right endpoint, so that's this, that's this, that's this, I think. Interesting question. Right endpoint. That looks right, I think. 4 rectangles with the right endpoints. What's this point here? That's 6. So that's 6 plus 2 minus, because this is an integral, minus 4 minus 6. So that's -2. That looks okay, I think. Anyway, we've done what they've told us to do, I think. Cool. Parts of the graph of y equals x squared and root x are shown below. Find the area of the shaded region. Cool. I'll just cast that. I mean, we can pretty easily see that this is 1, 1 straight away. Yeah, I'll just bring that up. Integral of 0 to 1 root x minus x squared x, so that's 1/3. The graph of y equals x squared is transformed to the graph of y equals ax cubed squared, so that's a dilation factor a from the x-axis, where a is, okay, so it's getting, oh, it could go, yeah, okay, sure. Find the values of a such that the area defined by the regions bounded by the graph of y equals ax squared and y equals root x, and the lines x equals 0 and x equals a is equal to 1/3. Okay, what? And the lines x equals 0 and x equals a is equal to 1/3. Okay, I'm sure there's just an integral you can literally write here. Ax squared. I'm assuming the reason I'm assuming that when you get when you dilate away from the x-axis, i.e. from 2, you're still going to get an area, so that's fine. What's the intersection points of root x and ax squared? That's x is equal to a squared x to the 4, and then x to the 4 x to the 4 a squared minus x is equal to 0, x x cubed a squared minus 1 is equal to 0, x equals 0, or x cubed a is equal to 1 over a squared, so x is equal to cube root of 1 over a squared, which is equal to a to the power of -2/3, I believe. Yeah, that sounds right. A to the power of -2/3, so 0. Oh, sorry, the area is already What? Okay, so defined by the regions, so there could be multiple regions. Ax squared, it could potentially be something like this. If that's the case, then a is equal to a half. The bundle of lines a. Okay, so if there's a dilation of less than 1, then that's fine. That looks fine. You're just going to get one single value of a here that where a is equal to 0. If you get a dilation of uh, a is greater than 1, so if a is less than 1, if a is greater than 1, between 1 and 2, aren't you going to get a dilation uh, that looks like this, for example, but the a value is now greater than 1, which means that you're going to get that a value here somewhere, which means that you're going to get this region here and you're going to get this region here. So the second integral is 0 to the intersection point, which I worked out was a to the power of negative 2/3 root x minus 8x squared. I just realized you guys can't see any of that, so that's my bad. Root x minus ax squared dx plus a to the power of negative 2/3 to a, but that's where the parabola is on top, so you get ax squared minus root x dx. So if I solve these two, I should get two different values for a, I think. So I'm going to bring my CAS up, solve menu for 3, 0 to a, root x minus a times x squared dx is equal to 1/3. Okay, two answers. That's cool. And if it's this time a to the power of negative 2/3 plus that, except I'm going to have a at the bottom. That's going to be the same. That's fine. Because this area is going to be, this is negative, but this is also negative. So you get that. Okay, so my three answers are those three. So I'm going to write those down. A is equal to 0.77. A is equal to 1.00. A is equal to 1.13. Okay, that looks fine. Question 3. State the maximum domain and range of Q. The maximal domain is, well, x squared minus 1 larger than 0 and 1 minus x is larger than 0. X is larger than 1 or x is less than 1. And here x is less than 1. So on the whole, x is less than 1. Yeah. Find the range of Q. As x gets, when x is 1, then when x gets smaller and smaller and smaller, you get this gets larger and larger and larger. This gets larger and larger and larger. This is a power of 2 factor, so I believe the answer should be larger and larger and larger. I think there should be an asymptote somewhere. I'm going to graph this to be sure, but I believe the answer should be actually not sure. So I'm going to graph it. How do I graph this again? Oh, insert graphs ln x squared. If I had more brain power right now, I'd probably try and graph it or try and use proper, but yeah, there is an asymptote here and that looks like it's going towards the reals, so it's just the reals. Because yeah, it won't stop at a single point, because when you sub in 1 here, you don't get a single point, so there will be an asymptote, and the power of 2 factor here is larger than this factor, so it should go towards positive infinity. Find the equation of the tangent to the graph of q when x is equal to -2. So I'm going to now define my function and then just use tangent line. So x equals to x squared minus 1 minus ln 1 minus x. And then I'm just going to use tangent line for tangent line qx comma x comma -2. So you end up getting y equals -x, and that looks about right from our graph. Find the equation of the line as perpendicular to the graph of x1, x equals -2 and passes through the point. Okay, so perpendicular to the graph means that the gradient is the negative reciprocal of -1, which is just 1, and it passes through -2, 0, which means that the graph is just y equals x plus 2. Yep, cool. You just have to kind of, I just visualized the graph really quickly and saw that it would go through, the y-intercept would be 2. Let p of x equals that. Explain why p is not a one-to-one function. The reason why p is not one-to-one is because, well, what's the best way to do this? Because I don't know how to, well, I could graph it. E to the power of -2x, that's a reflection in the y-axis, so that's that. That's a reflection in both axes, so that's that. When you add those, add 1. Or I'm gonna graph it to help me, because I'm not great with these random graphs, honestly. -2x minus 2 times e to the power of -x plus 1. Oops, that's a very rookie error. I used not the proper e, but the fake e. Minus 2 e to the power of -x plus 1. Okay, so I'm just going to kind of do this. You guys can't see that again. I'm so bad with this. What I did was I graphed it, and then I saw that the graph looks like that. It's about -2x minus 2 times e to the power of -x plus 1. Solve p of x is equal to 0.5. Okay, so actually no control exact value, no. Are these aren't exact values. What that means, okay, p of 1.22795. Alright, this is not a rigorous answer, but it will satisfy the question, I think. It probably won't get a mark, honestly, but that's fine. When y is equal to 0.5, Hence, it fails the horizontal line test. Ba-boom. Okay, so it's not 1-to-1. Find the gradient of the tangent to the graph of P at x equals a. Okay, so the thing I hate about the CAS section is that they're not even testing like understanding and whatnot. They're just half the time I feel like it's a CAS game where you just have to know how to use the CAS, and the way the exam is done, you're not even. Why is it so complicated? You're not even utilizing the CAS to the maximum. You're just using solve function and the random functions like this half the time. Why? Oh no, it's just the gradient. Oops. Sorry, that's a misread. So that's menu for 1 x p of x, and then I'm just going to sub in a manually. So you get 2 ln e. Wait a sec. Why ln e? Oh no way. Is that an x? Yeah. Sorry. I did my rookie error again, and that's not even p of x. I'm going to redefine p of x. You guys need to remember that this e here is minus 2x minus 2 times e to the power. So it's actually that e thing. E to the power of minus x plus 1. Yeah. And then, does this mean this is wrong as well? Yeah, okay, so yeah, that's dumb by me. I'm sorry. So I just adjusted this horizontal line test because it fails a horizontal line test because two y values are equal to each other. Find a gradient of the point. I was not great at demonstrating that I knew what was going on, but I fixed it up now. All you have to write here is a. So 2e minus a minus 2e minus 2a. Perfect. Okay. The diagram below shows part of the graph of P and the line y equals x plus 2. The line y equals x plus 2 and the tangent to the graph of P at x equals a intersects with an acute angle of theta between them. What's a again? Sorry, you're not seeing that again. Tangent to the graph of P at x equals a. Yeah, so okay. No, that's fair. That's fair. This has gradient 1. So if the angle theta is 60 degrees, or there could be more than one answer, so always look at this and then be aware of that. 60 degrees could be something like this, where that angle is 15 degrees. That is an example of 60 degrees. Or it could be the other way potentially. It could be like this. Sorry, it's messy, but the line could also cross it like this, where this is 75 degrees. So you can use m equals inverse tan theta. So m equals tan inverse 75 degrees, or m equals tan inverse negative 15 degrees to work out our two gradients here. I'm just going to do that first. Inverse tan, was it inverse control trig? Oops, what? Tan inverse, what's this? 15 minus 15 times, I bet in radians, so you have to do 180 over pi. Oops. I mean, that's fine, I think. And 75. Okay, so we get our two gradients here. They look like they're the same thing, honestly. Why is that? Why are they the same? Minus 15. Oh, they are the same. Which one is which? So the one here is the 15 degrees one, and that's 15 degrees one. That looks fair enough. How about the other one? Why is this one 75 degrees? Sorry, that's not 75 degrees, my bad. That's 105. 105. Sorry, this should be 105. And then you get 1.57 again. 105. 105. Maybe I've forgotten to do something. Anyways, the 15 degrees one is wrong as well. Because it's 15 degrees, which means it should be very close to 1. Wait a second. Oh no, m is equal to tan theta. What am I doing? It's an angle inside there. Okay, my bad. 105 degrees and 155 degrees. Or 65 degrees. That was embarrassing, but those two look better, I think. This gradient here is 0.9. No, it's not 0. It can't be 0.93. That's really close to 1. Am I sure about this? Maybe it is. Maybe I'm just kidding myself. No, it can't be. It's not even negative. Wait a second. Why am I... Wait, I should be turning into radians. Okay. My bad. My bad. My bad. My bad. 165 and this is what happens when you don't practice methods. It's the other way. This is 180 degrees. So I end up getting these two gradients. They look better. This one here, these two gradients look better. This one looks like minus 0.267. And this one here looks like minus 3. Oops. Minus 3.73. So we get our two gradients there, and then we just solve our above gradient formula for those. So I'm just going to define gradient formula 2 times, I'm going to remember to use E again, minus A minus 2 times e to the power of minus 2a minus 2 e to the power of minus 2a, and then that is solve m of a is equal to this, and is, wait, did I say 2 decimal places? Okay, that's fine. And also is equal to this. So that those two a values, do they look about right? One looks like around here, one looks, yeah, they look around right. So a is equal to, oh, I had no working. I'll just fill in the working afterwards. I'll just fill in the working now. Angles, m equals tan theta. Theta equals 50, 100 and 165 degrees and 105 degrees. Then you get two values of m, and then you solve them with 2e to the power of minus a minus 2e minus 2e to the power of minus 2a. And I get those two answers for a. Cool. Find the x-coordinates of the point of intersection between the line y equals x plus 2 and the graph of p. And hence find the area bounded the graph of y equals x plus 2, the graph of p, and the x-axis. Okay, so graph. So they're wanting this area here now. What's the first task? Find the x-coordinates of the point of intersection. Okay, so let's solve p of x is equal to x plus 2 minus 0.7. Exact. Both correct to 3 decimal places. So minus 0.750. Okay, and then hence find the area bounded by. Okay, so isn't this just a standard integral question? Minus 3 integral. Oops. Menu for integral. X plus 2 minus p of x. I don't see. Wait a second, is this the x-axis? Yeah, sorry, they don't want this intercept. They want this area. What am I talking about? They want that area. So this is actually just minus 2. The answer should come out as a... actually, no, I can't do that because there are two different areas. There's this triangle here, the area of which is... I'll have to calculate separately. So I'm going to start this again. Menu for 3. I'll copy this in. 0. So that's the area of that weird part over there. That's just the area under the graph of p of x. It will give a positive answer. And then we have that triangle as well. And that triangle is simply, I'll just use an integral, but you can just use a shape if you prefer. Integral of, again, I'm not showing you, negative 2 to this, x plus 2, x. And that's equal to that. So our final answer is those two added together, which gives us that. So our final answer my final answer is, I have to write the integral of, from negative 2 to negative 0.75 x plus 2 dx plus p of x minus 0.750 dx is equal to 1. Oh, sorry, is equal to 1.03809. So 1.038. Hopefully that's correct. Cool. Teacher coaches their school's table tennis team. The teacher has an adjustable ball machine that they use. Sorry, I just got a message. Has an approach that they use to help the players practice. The speed measured in meters per second of the balls shots by the ball machine is a normally distributed random variable. Sets the ball machine with a mean speed of 10 meters per second and a standard deviation of 0.8 meters per second. Okay, so determine probability W is larger than or equal to 1, 11. What, isn't this just menu probability distributions, normal CDF, normal CDF, PDF, normal PDF. Sorry, I should really know this because I teach this. Normal CDF. Yeah, okay. 11, infinity, And then that's, yeah, okay, sure. That's 0.106. Find the value of k meters per second, which 80% of the bores are below. Okay, so 80% of the bores are below. Menu. Isn't it just, again, just subbing it into the CAS? I hate these types of questions that don't require much thinking. Hopefully my thinking is not wrong, but 10, 0.8. Okay, I get that. 10.7. The teacher adjusts the height setting for the bore machine. Oh, my charger's not plugged in. The machine now shoots balls high above the table tennis table. Unfortunately, with the new high setting, 8% of balls do not land on the table. Let P be the random variable reserving sample rule that do not land on the table in a random sample of 25. Okay. Well, so mean is 2, right? That's 25, 8% of 25. How do I do this? Standard deviation. Oh no, sorry. Mean is p hat is the distribution, so mean is 0.08, because that's the mean. Standard deviation. Is there a formula for this? I think this is the formula. So I'm going to 0.08 times 0.92 divided by 25. Is that an exact answer? It's not, I think. Okay, so that's something you can always, like, if it doesn't say, that means you need a correct exact answer. Is this exact? I'm gonna try convert. So one thing you can always do is to convert these into exact answers. Okay, you do get that, so you have to write that, I think. Square root 46 over 125. Use the binomial distribution to find Okay, so you have to convert this into a binomial. If there are 25, then that's from 3 up to, so it's 3, so probability p hat is larger than 0.1 is probability x is larger than 3. So you can use a binomial for that. Sample of 25, probability is 0.08, and then, so you can't see that again, 0.08, and then you can use menu probability distributions binomial CDF. 25, 0.08, 3, 25. So then you get 0.323. There we go. Is that the end of the... No, it isn't. Okay. Cool. The teacher can also The teacher can also adjust the spin setting of the Bohr machine. The spin measured in revolutions per second is a continuous random variable x with a probability density function. Find the maximum possible spin applied by the Bohr machine in revolutions per second. Okay, so the highest value out of these. Well, this is a backwards line. This is a forwards line. So the maximum is at 20. So that's just 20 over 500, which is 2 over 50. Find the median spin in revolutions per second, correct to 1 decimal place. Okay, so the area under here looks like it's 20 times, what, 20 times 20 over 500, 10 times 20 over 500, 200 over 5, 0 0.4. So the area under this part is 0 0.4, so we need to find 0 0.1 essentially. You could use trapezium. You could use triangle to work out 0 0.5. Sorry, I'm just trying to do this by hand or in my brain. You can solve. You can solve essentially 1 over 25 times 50 minus x, or I'll just say a, is equal to 0 0.5. And then 25 times 0 0.5 is 12.5, so a is equal to 37.5. So hopefully I just point it up to there, and then they'll see my working. I think that's it. I did that in my head, so I'm not sure it's entirely correct. But 37.5, so 12.5. Is that even correct? That's not correct. No, that can't be correct. I'm gonna just not be lazy and use the integral. Or I could use a trapezium, but I'm gonna use the integral. Integral. Sorry, I'm gonna write solve. Integral 20 to a of 50 minus x. Oops. 50 minus x divided by 750 is equal to 0 0.1, and you get 22.619. So that's wrong. 20 to a, 50 minus x over 750 is equal to 0 0.1 because I worked out that this part is 0 0.4. I haven't done that incorrectly. That means that a is equal to 22.6. Okay, yeah, that's something you can see as well. If you get an answer that's 37.5 but it says correct to 1 decimal place, usually that means that, because 37.5 is an exact answer, so they won't say that usually if it's correct to 1 decimal place. Find the standard deviation of the spin in revolutions per second. Standard deviation, well, can't you just use the variance formula and then square root it? What? It's 3 marks, but integral, you just do that for both, don't you? It's just a lot of work. There's nothing hard about this question. It's just a lot of work on the CAS. So it's hard in that aspect. X, so that's e of x squared of the first part. 0, 20. That's the thing here. I don't even understand what's going on. I'm just minus the applying formulas, which can be bad. e to the power of x squared minus. So if I work out the expected value first, the overall expected value, what we have is x times expected. You can just add expected values. 20 to 50, and I'll put the second half of the function there. So 50 minus x over 750. 50 minus x over 750. On our times by x as well. So you get that. That should be the expected value. I haven't done something wrong. Now to get e of x squared. I'm not sure this is correct. E of x squared. Oh no, it looks correct actually. That's e of x squared, and then minus e of x all squared. So e of x is this, and that all squared is that. So that's the standard deviation. That's the variance. I have a feeling this might be wrong, but then I have to square root it. And then I get 10.2, 10.3. 10.3. Okay. Look, that doesn't look horrible. But I think I've applied the formulas correctly. Yeah, I think I have. Okay. Sure. The teacher adjusts the spin setting so that the median spin so the median spin becomes 30 revolutions per second. This will transform the original probability into a new probability, where g of x equals. Okay, so there are two dilations. Okay, so if there are two dilations, then the median spin becomes 30. There's a dilation factor A from the x-axis, dilation factor B from the y-axis. The graph looks something like this right now. Find the values of A, B, of which the new median spin is 30 revolutions per second. So if this is to be 30, then how should I do this? If this is to be 30, subbing it in, look, I could sub it in. I think I'm going to do that. It's grunt's work, but I'm just going to rewrite the formula. So f of x, sorry, a f of x over b is equal to x over 500. That's x over 500b times a, and a 50 minus x over 750. So 50 minus x over 750, x over b. Okay, so we get these two, and then the area under is, okay. Okay, so since it's been dilated by a factor of b from the y-axis, which means that everything's gotten further away from the y-axis. Yeah, further away from the y-axis, which means that the new domain is 0, 20b and 20b, 50b. So if I'm not mistaken, I can solve these simultaneously with the fact that the median is 30. The median should still be on that side, I think. Actually, it doesn't have to be further away from the y-axis. So what am I thinking? It could be either way. Uh, but oh, this just seems like a really bad way of doing it. The new median spin is 30 revolutions per second, giving your answer correct to 2 decimal places. What's another way I could do this? Well, the revolution. Well, well, actually, we know that dilation away from the y-axis, which is b, has to be uh, because the previous median was 22, now it's 30, which means that it's b is greater than 1, a is less than 1. What does that tell us? Could we potentially use the fact that the b is actually just 30 over the previous median, 22.6? Is that a possibility? Uh, let's see what that is. This part seems really similar to yesterday's exam. Where's 22.6? 22.6139. So if that is B, does A doesn't have to change by the same factor, which means that A should be worked out by using area under. So menu for integral 0 to 20 times b, so that's 1.32662, 0, a times x over 500 times b. I'm actually going to just ignore b. X plus menu for 320b to 50b, a times 50 minus x over b over 750 x is equal to 1. You solve for a, and b is equal to. So hopefully this will give an answer less than 1, and it gives that. Okay, so I'm just going to say that's that. 7.075, 0.75. Okay, cool. And b is equal to 1. I'm just going to say take that. I don't no idea if it's correct or not, but if I dilate it away from the y-axis, then the median going from 22.3 to 30 should be an indicator of what the dilation factor is. Because when you're dilating away from the x-axis, you're not changing the median. Are you? Um, Actually, are you changing the median when you dilate from the y-axis, from the x-axis? I could prove it, but I'm so tired. Um, I don't think you are. I'm just gonna take that. This was fun anyway, for fun. Part of the graph of that f of x is equal to the sine. Okay, set the period of f. So that's the period of this is 4 pi. The period of this is pi, which means that the overall period is 4 pi. Set the maximum value of f, correct to 3 decimal places. Minimum value of f. Uh, this value here, which is when you sub in pi over negative pi over 2. So when you sub in negative pi over 2, you get, that's actually not exactly that. So I'm going to use the cas. And there's no reason why it's exactly that. F of x, redefining f of x. F of x is equal to sine x over 2 plus cosine 2x. Okay, then what you have is, so I could solve that for 0. What's the best way to this? Solve. This is 1 mark, right? Solve. No, it's not. 0, oops, negative 4 pi x 0. So it has to be that very last one, which is 1.6, which looks about right because it's just just more than pi, which is what it looks like on that graph. So I'm just going to copy it and then f of that is that is it the exact value? Okay, so you don't have to give exact value, so it's just minus 1.722. So find the smallest possible value of h for which h minus x is equal. Okay, so this is a what transformation has happened here. This is x dash is equal to h minus x equals minus x plus h. So this is reflection in the y-axis followed by h units right. So reflection in the y-axis, yeah, followed reflection in the y-axis followed by h units to the right, positive value. Okay, so reflection in the y-axis means that you get 2 humps like this, and when's the next time you get 2 humps? You don't. What's wrong here? Sorry, this isn't the y-axis. It's a reflection in the y-axis, which means 2 humps here. Negative pi over 4, and then followed by h units to the right. So you get this shift here. So that shift here is half a period, isn't it? Yeah, so it's 2 pi. Consider a set of functions of the form g r to r. G of x is equal to where a state the value of a such that GA of x equals f of x for all x. GA of x is equal to f of x for all x. This is a dilation factor. What dilation factor is this? So I like doing this properly. X dash over A is equal to x over 2. So x dash is equal to 2a x. Sorry, no. A over 2x. So it's a dilation factor of a over 2 from the y-axis. Just checking it's the same with the other one. 2x over a. I think. Sorry, no, these two are different dilation factors. And that makes sense because the dilation away from the y-axis would never reach that. So there are two different dilation factors. Set the value of a such that GA of x is equal. So this is a dilation factor a over 2 away from the y-axis. This is the other one is a dilation factor 2 over a. This is 2 over a away from the y-axis. So a over 2 and 2 over a. What two dilations will give the same graph? Okay, so this is a really interesting way of thinking about it, I think. But what if these two humps here become these two humps? That's a translation though. Set the value of a. Set the value of a such that GA of x is equal to f of x for all x. What's this period here? The period of this graph is 2a pi, and the period of this graph is 2 pi over a. So in order for the graphs to be the same, the periods have to be the same. So a is equal to 2 because that means that this is 4 pi. Is that just it? In order for the graphs to be the same, the periods have to be the same. That looks okay to me. Okay, find an antiderivative of g of a in terms of a. Find g of a in terms of a. An antiderivative, okay, you can do this by hand, I think, equals a cosine x over a. Divide this, get a negative sine x over a. Minus plus a sine ax. Sorry, this should be over a. Okay. Use the definite integral to show that the area bounded by the graph g a of x and the x-axis over the interval 0 to a pi is equal above and below the x-axis for all values of a. Okay? Well, I mean, this is the period. So what you have to do is look at these 2 points here. You have to show that these 2 points are these 4 areas here are equal to these 3 areas here. So negative I'm going to solve for the intercepts. I'm going to define it first of all. Ga of x is equal to 0 sine x over a plus cosine a times x. And then solve Ga of x is equal to 0x, where 0x 2a times pi. What's wrong here? It's too complicated to be solved, is that it? Oh no, I mean, we're not even solving that correctly. We're solving the integral. No, we don't. What am I doing? Solve Ga of x. What's wrong with this equation? 0 to 2a pi. Okay. How do I solve for these points? Wait a second. Can't I just do one period? In order to show that the area above and below the x-axis is equal, can't I just do this and chuck it into CAS? Not, I keep thinking negative 2a. I just write 0 to a pi. This should equal 0. So if I chuck that in my CAS, menu 430 2 times a times pi Ga of this should equal 1. If this equals 0, sorry, this should. Why doesn't this equal 0? But it does equal 0, does it? Yeah, so that is equal to sine 2. Does this a squared? No, that doesn't equal 0. 4 over a. This doesn't equal 0 of a's of a. There's something I can do here. If I take if 2a pi is a period, then I can't split it, can I? No. It should be that this is equal to 0. Why doesn't this equal 0? Oh, a is a positive integer. Yeah, sorry, I forgot all about that. A is a positive integer. Yeah, which means that because this is when this is a positive integer, when a is a positive integer, uh, this is always a factor of uh, pi. In fact, it's always a factor of 2 pi, and so sine 2 pi is equal to 0. Sine 2 pi k is equal to 0 for k is an integer by definition. So yeah, okay, cool. Explain why the maximum value of GA cannot be greater than 2 for all values of A, and uh, why the minimum value of A cannot be less than negative 2 for all. Okay, so that's the same thing, essentially. Uh, it can't be greater than 2 because uh, because the greatest value occurs at, like, if we take a sine graph, the greatest value won't occur. I'm pretty sure you can literally solve GA of x is equal to 0, 2, and you won't get any solutions. Solve GA of x is equal to 2. You get solutions, why not? Oh no, of course, because the maximum values of each of those is 1. Yeah, no, sorry. Yeah, yeah. Maximum of each is 1, so can't exceed 2. And same for the minimum. Okay. Find the greatest possible value, maximum of each of the cosine and the sine. Find the maximum greatest uh, minimum value of GA. Greatest possible minimum value. Greatest possible minimum value. So the highest possible minimum value. Okay. So we make this as high as possible. If we look at this GA of graph here, sine A is a positive integer. A is a positive integer is a big part here because you can't. There's no point in using. Yeah. you would just try and dilate as much as possible from the x-axis, but these are dilations from the y-axis. So what? How is possible minimum value? These A's are dilations from the y-axis, not the x-axis. But they're not actually, no, they're not dilations from the y-axis because they're a different dilation factor in each of them. I'm going to try graph this. It's worth giving it a go. GA of x. Oh, great. GA of x. Find the greatest possible minimum value of GA. Greatest possible. So I think this is not in terms of A. I think that would have to occur when A is equal to 1. Because you get a trend where it gets higher and higher. It's closer and closer towards it. So when A is equal to 1, you just get the minimum value of this, right? So that's... sorry, you can't see that. So what I have here is a graph of the graph here, and as you get A is larger and larger, the minimum value becomes larger and larger, uh, smaller and smaller. So, I mean, lower and lower. So you need A is equal to 1 because A is a positive integer, and so therefore the value of the minimum should be that. So negative 1.41. Okay, it's not, it's an exact value. So I'm gonna try and chuck this in the CAS GA of x. So let's just say n is 0, then you get negative pi on 4. So GA of negative pi on 4. So that's what? Sorry, I'm not solving GA of x equals 0. I'm solving GA of x is equal to 0. X. So I have to sub in negative 3 pi on 4 into GA of x. Negative 3 pi on 4. And I get negative 1 point. Is that the same value there? Yes, it is. So the answer should be that's without what? Why is it a decimal? And why can't I write anymore? What's wrong with this? Okay, but anyway, the maximum value minimum should be this, but in terms of GA. So we already have GA as that. Is it? Why is GA that? Oh no. Yeah. No, because A is already defined as 1 here. So I'm just going to do this manually. Because, yeah, that's the thing with the CAS again. If you have it open in the other tab, you get weird answers. Negative root 2. So that is the answer. Ah, yeah. And that is... Why doesn't this work? Negative root 2. Okay, so that was my attempt at the extended response. Hopefully most of it is correct, but no, I make absolutely no guarantee that's all correct. Again, this is all owned by Vika. Thanks for watching. Please subscribe.